So earlier in the polynomials, you looked at end behavior, and that's what you were sorting earlier this week and last week. So if you recall, you either have a u where both ends go up, or that negative leading term would make them open down. And if you had an odd power, so this is when you had an even degree, and this kind of shape, which I like to call an S shape, it's kind of this curvy thing, or a chair, that happened when you had like an odd degree. And if you recall, the degree is the largest exponent, so it could also go like this depending on the leading term. So if I give you a polynomial, the hope is that you can look at this polynomial and at least tell me the shapes. We're trying to make you kind of like a calculator, but not necessarily finding all the pieces and parts. We want you to look at something and know what it's going to be. Because this power is odd, it's 5, so the degree equals 5. So it's this chair shape. Notice my chair rows left to right. Now, not all the time will it be expanded out. Some of you were trying to add the 5 and the 1. You don't add exponents when you multiply. So if I give you a situation like this is called factored form. Just a reminder of that. This degree is not 4. The degree on this is also 5. Well, how come it's 5? Well, if I look and expand this, notice this is multiplication, and that's when exponents change. So if I wanted to expand this, I could take x plus, I'm going to start with the x plus 3 to the power of 4, and what that really means is x plus 3 times x plus 3. That's 2 of them. Some of you know to build a box. It's not typically the way I do it, but it definitely works. And all I'm doing is multiplying. What I like to do is show the distributive property. X times x is x squared. If I continue, I get 3x, and then I must distribute. So it's just called double distribution. It's really how multiplication works. So that's 2 of them. I'm going to condense that. And then I need to multiply this by a third. Now, how would I do that? Well, if I had a box method, I would have the 3 pieces across the top and the 2 pieces down the side, and then I would fill in each one of these boxes here, and that would find it for me. I personally like to use the distributive property. So what I'm going to do now is I'm going to distribute this x to all 3 of these, and I get x cubed plus 6x squared plus 9x. Now I must work on the 3 and do the same thing. I line them up. Why did I line the 2x squareds up? Because I know I can add them. They're common terms, or like terms. If I add here, I get 3 times 6 is 18x. Notice those will add up nicely. And lastly, I'll get 27. Now, how many x plus 3's have I done? I've done 3 of them. So when I was done with this, I would total these up, adding again the like terms, and I would again multiply that by x plus 3. So in the first part of the Desmos activity, it's going to ask you a little bit about end behavior, and then it's going to ask you to do some expansion.